1. Different fields. These are pages I write about the foundations of scientific thinking addressed to the general reader. The first thing I want for this general reader to understand with crystal clear clarity, in order to avoid any confusion between similarities, it is that a person has different fields in which he moves with his mental activity. Science or thinking according to the scientific method is not his only field. Rather, he has many other fields, and each field has its own standards. If we say in the following pages that the scientific method requires such and such conditions and rules of conduct, we only mean the field of science and what revolves around it, and as for fields of human activity other than science, this is not our topic here. What we will summarize here does not apply, for example, to the field of art and literature, nor to a person's emotional life in general. The issue in a person's comprehensive life is not to say to him, either you have a scientific approach in your thinking or you do not. No, rather a person's business in his life is to be this and this and that in one life. However, he is required to adhere to his appropriate approach in every field, provided that we remember here that suitability in this or that field is not an imposition imposed on a person from where he does not know, so he has no choice but to reject what has been imposed on him. Rather, it is an obligation imposed upon him. His commitment in light of humanity's experience throughout its long history. If we are told, the method of knowledge is such and such, this meant that man's experience in his attempts had indicated that this particular method was the best path to proceed in the field of scientific research, without this preventing him from introducing any modifications to it that turned out to be the best. If a poet like Abu al-Ala said, "I think the surface of the earth is only made up of these bodies," it is not permissible for a geologist to criticize him and say, "You made a mistake," because the surface of the earth is not limited in its elements to the elements that make up human bodies, but rather it contains what is not in these bodies. Of elements, no, a geologist should not object to a poet like this, because the poet has a standard by which his poetic correctness can be measured, other than the standard by which right and wrong in science are measured. When Abu al-Ala said that the surface of the earth, in his opinion, is nothing but human bodies that were like our bodies, but death came to them and they decayed and decomposed and became dust from this dirt that we step on with our feet, he only wanted to limit man's arrogance in himself, which is a goal that is not closely related or related. From afar, with the aim of a geologist when he analyzes the earth's soil into its elements to know what its components are, both poetry and science have a special balance. As for the balance of good poetry, it is the business of literary critics, and as for the balance of correct knowledge, it is in the hands of those who are familiar with the principles of the scientific method. If we limit ourselves here to the field of scientific thinking alone, it soon becomes clear to us, after a closer look, that the content of the field varies greatly. Some of this content only applies to a narrow field in the world of things, and some of it extends its application even to include all, something in existence. Compare, for example, between a fact said about the cotton worm, how it is born, lives, and how it dies, or another fact said about Mount Mokattam and its types of rocks, or about the High Dam, the way it was built, and the goals it achieves. Compare such facts with a fact about the speed of light, or a fact about the composition of the atom, etc. There is something escaping in it, or about gravity and its law. These are all comparisons that come out with a conclusion, which is that scientific facts are not all of the same degree, but rather they are degrees that rise in terms of abstraction and generalization. Since these two words, abstraction and a generalization, are of great importance in our perception of the foundations upon which scientific thinking is based, let us dwell on them for a moment in this place in the context of the hadith. As for abstraction, it is, as is clear from the direct meaning of this word, the removal of attributes from things, which is characterized by it, just as we remove from the wearer the clothes that cover him. If this, which I have in my hands now, is a specific, special pen, perhaps I can distinguish it from all the other pens by individual signs that I recognize in it. Then it is a thing in itself, a known determinant, with its own individuality and specificity, and it must have a known place at every moment of time. But this pen of mine is neither the first nor the last pen in this world, which is full of things. Rather, there are many other pens, which were, are, and will be. Even if they differ in their colors, sizes, and manufacturing methods, there is an aspect they share in common. Otherwise, it would not be right for us to share all of them in one name that calls them, which is the named pen. If we reach the point where we call this comprehensive name despite the differences that distinguish some of them, then it is necessary we would then have subtracted from our minds a large number of their partial characteristics in which they differed. We must have subtracted the characteristics of color, size, and method of manufacture in order to preserve the task that it performs, which is the subject of commonality between them. But when we strip away the characteristics that distinguish it from individual pens in this way, then we have distanced ourselves from the sensory reality as it actually occurs and as you perceive it. Indeed, our senses, since sensory reality contains nothing but individuals and vocabulary, and our senses sight, hearing, touch, and so on can only relate to those individuals or vocabulary. However, if we strip these partial, real things of their qualities by which they are identified, I mean, if we strip them of those qualities they used to have, such that what remains for us of them is nothing but an idea or a mental concept, which is not what sight or hearing perceives, but rather what the minds imagine it, then our tool in the process of perception is the mind and not the senses, even though this mind did not perceive what it perceived except based on partial pens in the world of tangible reality. This is the abstraction that, if you enter the field of scientific thinking, you see as a condition in every scientific idea. Our knowledge of one particular is not science, because a single particular, isolated from everything else, is not like the general scientific laws that include it and other members of its kind. Perhaps you noticed in these last two lines the words knowledge and knowledge, when we said that our knowledge of a single particular is not knowledge. Which shows you that knowledge of things is broader than the knowledge specific to them, so not everything you know is a type of science, but every scientific fact is a type of knowledge, so you may know characteristics that distinguish your father, brother, or friend from all other people, so that is not the case. What we mean by psychology or other human sciences is because these sciences strip the partial knowledge of its individual characteristics to arrive at an idea that includes all of them, and here the idea becomes a scientific as long as it is truly based on pillars of partial knowledge that we have correctly understood. The abstract idea, if we reach it, we necessarily find it to be a general idea that applies not to one individual or one partial position, but rather to a group of individuals or a group of homogeneous positions. You will see in the following pages that one of the most specific characteristics of scientific thinking is its access to general laws in the light of which we understand partial facts. Yes, science begins with the study of specific, single, partial facts, but these facts are not in themselves science, because science cannot exist unless we reveal the general laws that constitute each of these partial truths as an application or embodiment of them. The importance of partial facts is that they are the first path that leads us to the laws of science. The facts of the world that surrounds us are, on the surface, disjointed and dispersed facts. The passing eye may not see a relationship between that cloud floating in the atmosphere of the sky, and this river following its course, and the movement of the wind whose rustle we hear in the tree leaves, and the heat of the sun that we protect in the shade of those leaves. These and others may appear to be separate from each other to the passing eye, until systematic thinking deals with them, and if it links these miscellaneous ones into a consistent group, we call each consistent group of them the name of a science. Astronomy, for example, is a set of laws, each of which is summarized. A description of the movements of celestial bodies as seen in their details and details. Botany is a set of laws, each of which is a summary by which we generalize characteristics that we have observed in different types of plants. Economics is the body of general ideas, that is, laws that we have derived from observing the processes of production and distribution. Psychology is the set of general laws that we extracted from the patterns of behavior that we saw in individuals and their interaction with each other, and so on. We go back and say, the single particle that you encounter in the world of reality is not science, even if observing it and conducting experiments on it is our first path to science. Rather, that single particle, while still in its isolation, cannot be understood unless we realize the connections between it and others and are able to formulate those connections in what we call the laws of science. Only then do we understand the single particle in the light of the scientific law that contains it and its likes. If it has rained now, I know that there are drops of water falling from the sky. In fact, perhaps my imagination wanted me to have different thoughts about this falling water in terms of its source and the reason for its fall. Even if my scientific thinking ended up linking this falling water to other phenomena related to it, temperature, humidity, wind direction, etc., i.e. understood the phenomenon of rain, and it was no longer room for delusional thoughts for me to flounder around. Understanding a phenomenon means finding the link between it and other phenomena in one law. If you do not find the law that includes it with similar phenomena, it remains an incomprehensible phenomenon. The doctor understands the pathological phenomenon that he is about to examine if he knows in which category to place it. The merchant understands the rise or fall in the price of a particular commodity if he finds a relationship between that commodity and other facts attached to it, such as the amount of it produced, what the world's markets offered, and so on. If you knew thousands of partial facts about nature without finding the connections that follow them in sets of laws, then this knowledge of yours is not science at all. The villager who sees a solar eclipse or a lunar eclipse is not an astronomer with his knowledge of this single detail. Because he realizes that partial truth, which is isolated from all other facts related to its occurrence, such as the position of the moon in relation to the earth and the sun and what this position entails based on the laws of light. Knowing one partial truth does not help us predict what will happen at a future moment, but if we know the connections between various things, which we generalize, it becomes a scientific law. Then it is possible to predict precisely what will happen when it will happen, and how it will happen if those connections exist in the given circumstances, as determined by the scientific law. This linking of miscellaneous things that co-occur together is a solid foundation of scientific thinking. If several aspects are interconnected in one group that is related in their occurrence, such as a patient's temperature, his way of breathing, his blood pressure, and other aspects that the examining physician tracks, for he can infer some of them from others, according to the general law that holds them together, and you should notice here carefully that superstitious thinking, in turn, attempts such a link between miscellaneous things, such as linking a crow to caw when traveling and some danger befalling the traveler, or linking visiting shrines and healing the sick. In the case of superstitious thinking and in the case of scientific thinking equally, we see the attempt to link events and things in a way that helps us predict the results, had it not been that scientific thinking has something that superstitious thinking does not have in terms of accuracy of observations and scrutiny of results, as we will discuss in detail later. I repeat here what I began this first paragraph of the conversation, which is that what is not accepted by science in its field, due to the absence of the conditions required by the method of scientific thinking, may be acceptable in other fields, but in these pages we are concerned with science alone. ###2 and various sciences. If we enter the arena of sciences, we find different types of them. There are sports sciences with all their branches, just as there are natural sciences of all kinds, and in addition to these and those there is a third group that they are confused about naming. Sometimes they call them social sciences, and at other times they prefer the name human sciences. Perhaps the first question that imposes itself upon us when seeing these different types of science is, do all of these share a single intellectual pattern that we want to call scientific thinking? If the patterns of thought are different according to these categories, in what do they agree that it is permissible for us to include them all in one field? The truth is that the answer to these questions has not been a single answer throughout the ages. For many centuries, people have believed that the method of scientific thinking is one and not multiple. If we see that this method sometimes leads us to certain results, as is the case in the mathematical sciences, and other times that are uncertain, as is the case in the natural sciences and social sciences, then we must in this case, philosophers of science must analyze the method of mathematical thinking that leads to certainty. What are its components? In order to expand its application such that we use it in every subject that we claim to be science. It was such an analysis through which the Greek philosopher Aristotle established the science of logic, as he put it, and as it continued to remain the method of scientific thinking that had no other method, until history ran its course for about 20 centuries. That is, from Aristotle in the 4th century BC until approximately the 16th century AD, with exceptions along the way, such as those that occurred at the hands of a group of Arab scholars. The established idea throughout those 20 centuries was that scientific thinking had one method, regardless of the subject of science. There was no difference in that between a science that investigated engineering, a second that investigated chemistry, or a third that investigated methods of human behavior. In all of these cases there must be. First of all, we have in our hands a set of axioms that we accept as we accept the foundation on which a building is built. Then comes the process of scientific thinking, which is to deduce from those axioms what it is permissible for us to deduce, as long as the first axioms are certain of their validity. The conclusions we draw from it are also certain to be correct. Within the framework of this single approach, if the person with an idea presents his idea to the people and the people want to verify its correctness, they demand that he return that idea to the principles from which he extracted it, on the condition that those principles come from the axioms that these people place on their own terms. No matter how many steps the investigator takes back from the alleged idea to its first origins, the connection must be close between each step and the previous step, until the investigator reaches the point of starting from the postulates. It is not knowledgeable what someone says without a chain of transmission of this kind. But such a course of action requires the walker to move from the sentence in which the idea to be realized was formulated, to a second sentence that was its origin, and this to a third sentence, and this to a fourth sentence, as if the path of knowledge is moving between sentences on the pages of books, as if there is no nature there. It surrounds a person and he wants to know its phenomena. Such a process, which keeps deriving sentence from sentence, is close to what happens in the field of mathematical thinking. Because the construction of mathematical science is based on axioms that we impose for ourselves, and then we extract from them what we are permitted to extract, so that mathematical proof is always the return of the result to be proven to the original from which we extracted it. The question remains, would such a course of action be the same as the method of the natural sciences? The answer was positive until the European Renaissance, with a few exceptions that emerged in a group of Arab scholars. They are few because they are not what characterize the general character of the intellectual climate as a whole. On the one hand, there are mathematical scientists, and by the nature of their knowledge they must follow the path that begins with axioms and then produces results from them. On the other hand, the majority of those with scientific thinking were men of jurisprudence, men of linguistics, scholars of theology, and those of philosophical schools of thought, and all of these, by the nature of their own fields, must follow the same path in thinking, which is thinking that begins with what is not a subject of controversy. Let their efforts be devoted to drawing conclusions only, without the possibility of doubting the origins from which those results were extracted. But the matter has fundamentally changed since the European Renaissance, which was the gateway to what we call the modern era. Here, the natural sciences began to take a place for themselves that they had not had since the beginning of history. We say this without ignoring the leaders in those sciences who came before the European Renaissance. Among the scholars of ancient Alexandria was Archimedes, the author of the law of floating bodies, and among the Arab scholars was Jabir ibn Hayyan, the founder of chemistry, but all of these people were not numerous, nor did their approach have such control that they would have the upper hand and become the character of the era, as was the case for naturalists in the Renaissance, and because of their approach based on studying nature and its phenomena, not studying nature as it is described in books, I say, they and their method had the dominant dominance, so they marked the era with their character, and historians were able after that to say, here a new science and a new scientific method were born. The novelty was that scientists replaced reading pages with reading nature itself, and the authority they rely on for what they decide about beings and phenomena is not that they refer to a text in a book. Rather, it is for them to return to what can be seen in natural phenomena as perceived by their senses. Then this distinction between the pure mathematical way of thinking and the way of thinking about the phenomena of nature became clearer and clearer, in light of what logical analyses of scientific facts had concluded since the middle of the last century, the 19th century. Since then, decisive differences have become clear between the intellectual unity in the mathematical structure and the intellectual unity in the natural sciences structure, which makes each of the two structures have an approach that is not suitable for the other. Of course, this difference between them does not negate the fact that each of them is dependent on the other in the context of one research. While the unit of mathematical thinking is analytical in the way it is constructed, the unity of thought in the natural sciences is synthetic in the way it is constructed, and what is meant by the analytical structure in the mathematical sciences is that it is based for its validity on the law of identity. That is, the mathematical equation, for example, does not mention in its other half except what it mentioned in its first half, with the symbols used in each of the two parts being different. That is, the other half of the mathematical equation is the first half after replacing one garment with another. Our saying 3 plus 2 is equal to 5 means that 3 plus 2 is the same as 5, despite the difference in the symbols indicating the same truth in the two cases. If a questioner asks and says, "What do we know that this is a correct equation?" Our answer was not to identify it with any of the external objects of nature. Rather, our answer in this case was limited to reviewing with him the way in which we analyzed one of the two parts in an analysis that places its elements without addition or subtraction in the other part. Therefore, the truth of the mathematical sentence lies in the way it is formed and is not based on any evidence from outside it. As for the unity of thought in the natural sciences, it is another matter. Because in this case I do not analyze one part of the sentence with the other, but rather I add to the thing I am talking about information that would not have been deduced from it if we took it in its known meaning. If I said about light that its speed is such and such a mile per second, then this aspect that I was adding was new. I would not have arrived at it if I had begun to analyze the concept of light itself as I knew it in my direct experience, or if I had said that the average income of every Egyptian is approximately 100 Egyptian pounds. In general, here too you see that the news I am narrating about the average income could not have been deduced theoretically only from my mere analysis of the elements that make up my concept of the Egyptian and the way he is formed. Therefore, if a questioner asked this time, saying, "What makes us know that this is really the speed of light or that this is the average income of an Egyptian?" our answer was not the same as it was in the case of the mathematical equation. Rather, the basis here is that we go out with the questioner to the external truth to review the alleged truth. If it matches the alleged truth, then it is true. Otherwise, it is not a truth as we claimed it to be. There are two groups of sciences, differing in subject matter and method. Scientific thinking in one of them has foundations other than the foundations required for scientific thinking in the other. We are left with a third group, which is what may be called the human sciences or social sciences, such as the sciences of economics, sociology, psychology, politics, and others. These raise a problem among philosophers of science to this day, as some of them want a method for them. Its own, that is, foundations for scientific thinking that contradict the foundations of mathematics and the foundations of natural sciences together. Some of them see it being included in the group of natural sciences, because it examines man in terms of him being a natural phenomenon like other phenomena. If he has other aspects that distinguish him, then they are not what we mean by scientific study, and perhaps we will return to detailing that in another place. 3. Pause when thinking mathematically. When questioners ask about the foundations of scientific thinking, very often minds turn to one of the two types of this thinking, which is that which takes place in the field of experimental natural sciences. The questioners or respondents rarely realize that there is another type, which fundamentally differs from the approach of the natural sciences from top to bottom. He introduced it, and by it I mean mathematical thinking, taking the word mathematics here in its general sense, which includes, along with the sciences of algebra, arithmetic, geometry, and so on, other sciences whose language is not numbers, but which nonetheless follow the same approach in the steps of the process from the first hypotheses down to the results that are generated of those assumptions. This is because mathematical thinking is characterized by its two-step process. The first is a step in which assumptions are made that are required to be accepted, not because they in themselves must be accepted in all circumstances and for every person. Rather, it is because the researcher wants to base his results on them, so that the critic may not then direct his criticism to the hypotheses themselves. Rather, he must then limit his criticism to the method of deducing the results from those hypotheses. If the entire intellectual structure is not acceptable to its critics, then their path is to reconstruct it based on other hypotheses they put forward in order to produce results different from the results of the rejected structure. We cite this as an example from current life. If the assumption is that the average income of a single Egyptian is £200 per year, then if we also assume that the number of Egyptians is 40 million, the inevitable result was that the national income in Egypt was £8,000 million. The reader notices in this proverb how this aforementioned result is not described as right or wrong except on the basis of the assumptions that we made and derived the result from them. The intellectual structure here is sound as long as the assumptions are agreed upon, and as long as the result was deduced in a correct mathematical manner. However, if a critic wanted to make other hypotheses, such as making the required average Egyptian income £300 per year, while agreeing with the number of Egyptians 40 million, his result would differ. This time, the national income in Egypt must reach 12,000 millions of pounds. The very important point in this discussion, which we want to draw attention to, is that the assumptions made by the person who thinks mathematically, whatever his subject, are not the subject of discussion and controversy. Because hypotheses, by the nature of their name, are not among the issues raised for research. Rather, they are equivalent to us saying, if the matter is such and such, then the result will be Kate, and the sentence preceded by the conditional if does not claim that its speaker indicates an actual fact. So you're saying, for example, if it rains, I will have to stay at home. He arranges a conclusion on the assumption that it will rain, without claiming that the rain has fallen or that it will definitely fall. Rather, the result depends on the occurrence of this assumption. If it occurs. The historical model of mathematical thinking for centuries has been geometry, as developed by Euclid. In it, that pioneering mathematician began with axioms to begin the mathematical intellectual construction, and he divided those axioms into three types. First, he provided a number of definitions by which he specified what he meant by words of importance in his context, such as point, line, surface, and so on. Secondly, he mentioned a number of facts that are required to be accepted without proof, and he called them axioms. Thirdly, he listed another number of facts that must be accepted in advance, and called them assertions. The main difference between the group of axioms and the group of presumptions, both of which are required to be accepted without proof, is that the axioms revolve around ideas that are not from the field of geometry itself, while the presumptions are ideas taken from the field of geometry, which is the field of research that Euclid is interested in dealing with. While the axioms mention to us facts about arithmetic expressions or concepts contained in arithmetic, such as the concept of addition or the concept of equality. You see the confiscations based on geometric concepts taken from the same field that is the subject of the research, such as parallel lines, for example. Since the time of Euclid himself, an Alexandrian scholar around 300 BC, until the 19th century, people have had no doubts that the assumptions upon which Euclid based his geometric theories are not merely assumptions that can be changed, but rather they are, at the same time, indicative of the facts of external nature as they actually exist. If Euclid, for example, said in those hypotheses that two parallel lines do not meet, no matter how far they extend, because this is the reality of the two parallel lines in external existence, it is not surprising that the main problem around which the great German philosopher Immanuel Kant revolved his entire philosophy, Kant was born in 1724 AD and died in 1804 AD, is this question, since the axioms in Euclid's geometry were produced by pure reason, not deriving them from the experiences of the senses, and yet it is identical to what a person finds in external existence, as indicated by these experiences. How could pure reason produce from itself facts that match what is actually reality? I say that people have remained throughout these centuries, and they see the axioms of sports as not just assumptions that can be changed with something else and the results change accordingly. Rather, they see in it evidence of the facts of actual existence. Until it happened during the 19th century that mathematicians asked, is it not possible to change this, or that axiom of Euclidean geometry equals the geometry left by Euclid? And if we change those axioms, what are the new geometric theories? These mathematicians actually made such a change, especially in the confiscation of the two parallel lines that do not meet, or the two non-parallel lines that must meet if they are extended, and this heralded the birth of a new era in sports science, the most important characteristic of which, from our philosophical point of view, it is that mathematical science does not in itself indicate external reality, but its validity is limited to the validity of inference from recognized hypotheses. With the possibility of changing those hypotheses if we wanted to establish a second mathematical construction, then changing them again to establish a third, then a fourth, then a fifth mathematical construction, so whatever mathematical intellectual constructions you want, all of them are correct, as long as the results, i.e. theories, are inferred properly from the imposed axioms to be the basis upon which the building is built. This means that mathematical facts are as numerous as the mathematical systems that we evaluate, and of these systems in themselves, we cannot be certain which one applies to external nature. We said that what distinguishes mathematical thinking is that it proceeds in two steps, the first of which are axioms whose correctness is assumed without proof, and the other is the theories or results that we derive from those axioms, and they are theories on which we establish proof. The way to prove it is to rely on axioms. Every truth that we see as derived from one of the axioms or from a few axioms taken together, we consider it to be a proven fact, not because it inevitably applies to natural reality if we want to apply it, as it may not be so, but because it was derived from the hypotheses derivatively intact. This two-step mathematical approach is not limited to the mathematical sciences in the narrow sense of this phrase. Rather, it is an approach used by the human mind in many other fields, in which researchers would begin to proceed from what is recognized as correct, either an assumption based on a mere assumption or an assumption based on other foundations. Then we see these researchers spending their intellectual efforts in the process of extracting the necessary results from that beginning that was the subject of submission in the first place. In all such cases, what is the meaning of a scientific thinking except the ability to draw conclusions from premises that are assumed to be correct by virtue of the assumption? Scientific thinking here has nothing to do with the universe and what is in it. He has no business matching the statements to the facts. Rather, his business, all his business, is in tightening the inferential relationship between the origin and what branches from it. Let us take examples of this type of a scientific thinking that follows the mathematical path without its subject being mathematical science in its narrow sense. English philosophy in the 17th century witnessed a struggle over political theory between two men, namely John Locke (1632–1704 AD) and Thomas Hobbes (1588–1679 AD). The first of them holds that the king is chosen by the people, and therefore the people have the right to remove him if they do not find that he has fulfilled the trust in the desired manner. The other holds that the king, in the historical origin of monarchy, did not come as a result of a choice by the ruled people, but rather came as a result of his power that he imposed. It is imposed on the people, and therefore the people do not have the right to dismiss him or put him on trial. Each of the philosophers came to his political doctrine based on an assumption he imposed for himself about the origin of human society. How was it at the point of its beginning? Locke said in this regard, individuals of the people wanted security for themselves, so they chose from among themselves an arbitrator who would rule between them fairly if a dispute arose. If this was the assumption, it would produce the necessary result, which is that the people who chose have the right to retract their choice. As Forg Hobbes said otherwise, his assumption in the establishment of society from the beginning was that a man was distinguished above all other individuals by his power, so he imposed his authority on everyone and made himself an arbiter among them. So the inferential result that was necessary from that would be, it is for that man to be the author of the laws, therefore, no one of his subjects has the right to hold him accountable for an act he performs or a ruling he orders. What do we say about these two theories of government policy? Is it possible to say which is right and which is wrong? Scientific thinking here is to take each theory in terms of its derivation from its hypothesis. If the derivation is sound from a logical standpoint, the result is correct from a theoretical standpoint. But what are we to do if we examine the situation and find that both theories are correct in terms of the safety of deriving loans? In this case, we can only choose on the basis of the practical benefit for the particular group at a certain stage in its history, without us having the right scientifically to accuse the other theory of error. The matter here is like the situation in several mathematical constructions that we based on different sets of axioms, each mathematical construction of which is true in itself. Even if one of them was chosen over the others in practical application, this would not mean that the rest of the constructions that we did not choose are wrong from a pure mathematical point of view. Or say, with another analogy, that in this case it is as if we are looking at the 3 pyramids of Giza, each of which has its own building, and judging one of them is not significant in relation to judging the other 2 pyramids. If one of them has some error in its architectural foundation, it does not indicate this has something to do with others, as these 2, or one of them, may also be wrong or they may be right. This point, to me, is extremely important in the foundations of the scientific thinking. Because if we explain it with the clearest clarity, and if we digest it and assimilate it, it will be the best help for us in establishing the correct, upright, and inherently tolerant scientific outlook. This is because all doctrinal structures are based on this mathematical basis in the approach to thinking. As each structure has its own first assumptions, and from those assumptions that are recognized as correct by their authors, results are produced. If we find ourselves faced with several doctrinal structures in the world of politics, society, or other things, each of which has its first foundation from which a group of beliefs, ideas, or rules are derived, then we find at the same time that each of them is equally correct in logical reasoning, so extract its results. From its origins in a sound extraction, it was then scientifically impermissible to make a comparison between the constructs from a purely theoretical point of view, but the comparison should be made, if we wish, on the basis of practical benefit in relation to specific partial cases. For the sake of further clarification, we say, suppose that there are 2 story writers, each of whom wrote his story about an uninhabited island. One of the writers chose for his story to have one man settle on it, and then he began to trace his life on the island to see how its events unfolded, while the other chose to cut off the road. Not by one man, but by the passengers of a ship numbering a few dozen persons, he, in turn, began examining with his imagination the details of their life on the isolated island, what it might be like. Then a literary critic wanted to evaluate the accuracy of the imagination of each of the 2 writers. Is it permissible for such a critic to hold each of the 2 writers accountable except on the basis of his first assumption? The writer who assumed the existence of one man must adhere to this assumption in the details of his story. If he claimed, for example, that this one individual had erected on the island a pyramid like the Pyramid of Khufu in Giza, the critic would say that he is unimaginative. Because one man cannot do it alone, and so is the case with the other writer who made his starting point a large group of individuals, the critic keeps that general framework in mind when he looks at the possibility or impossibility of what is happening. For another pause at the experimental method. Here we may prolong the pause a little, because this type of thinking, which is the focus of the natural sciences and what takes place in terms of the method of conduct, is usually what occupies people's minds if they discuss something related to a scientific thinking. They rarely remember that the process of drawing conclusions from hypotheses, whatever those hypotheses may be, is also scientific thinking of great importance in man's mental history and in his scientific positions in various fields. I say that people rarely remember that, and that they are primarily concerned with nothing but that kind of scientific thinking that focuses on nature and its phenomena. What is noteworthy is that while mathematical thinking, in the broad sense of this phrase, that is, the meaning that applies to any intellectual process that derives results from the hypotheses, I say that while mathematical thinking is ancient and goes back to the roots of history, we see scientific thinking in its natural experimental sense as newly born and newly emerging. In general, it can be said that all of ancient Greek thought and what followed over the centuries of the Middle Ages was mathematical in its approach. meaning that it was a thought that placed in its hands a recognized principle or principles, and then proceeded to extract the inferred facts that resulted from it. This was the philosophical thinking of the ancient Greeks and of those who came after them, when the philosopher had to set for himself a principle that he would take as the spring from which all parts of the philosophical system that he established emerged. However, the validity or invalidity of these parts is based on their necessity or non-requirement regarding the initial imposed principle. On this same basis, Aristotle established the origins of his formal logic. At its core, Aristotelian logic is nothing but a syllogistic process topped by premises from which we can extract the result. We do not say that this result is correct unless we find it generated from those premises in a way that adheres to the rules of analogy. If we say Aristotelian logic, we are saying, roughly speaking, all of human thought for nearly 20 centuries after Aristotle. It is no wonder that studying this Aristotelian logic was almost a necessary condition for every intellectual in those times, regardless of his orientation, whether he was a doctor, a jurist, a literary critic, or whatever trend you like in people's intellectual lives. Thinking according to the mathematical approach, then, was as old as intellectual history, and as for thinking according to the experimental approach, it did not crystallize into a trend that had comprehensive dominance in all scientific life, except during the European Renaissance in the 16th century or thereabouts, and I repeat what I said earlier. Although individual exceptions had preceded that date, especially in Arab civilization, which witnessed prominent figures in the field of experimental science, such as medicine, chemistry, navigation, and so on, but all of that did not imbue the era in general with its character, and the era remained marked by a mathematical character that derived results from postulates. In the most important aspects that had the greatest importance in people's lives, such as language, jurisprudence, and theology, the last 4 centuries, which we call modern times, are characterized by this shift in the method of scientific thinking about nature and what is in it, from a mathematical approach to another experimental approach, which is based primarily on observing what is happening in the real world. Let scientists propose theories to control the way in which the events of that real world are expelled. From them are the laws of science. What are the most important characteristics of this type of scientific thinking? We mentioned 2 of them previously, namely, abstraction and generalization, and they are 2 aspects that do not raise controversy among people whenever the discussion revolves around scientific thinking and its foundations, so we leave them and move on to other important characteristics. 1. Converting quality to quantity. It is the reader's right, before we proceed to talk about this characteristic of scientific thinking, to define for him the intended meaning of these 2 important words in the entire field of philosophical thought. One of its aspects is the philosophy of science, which we are now about to talk about. As for how, we refer to the characteristics of things that we might mention if we were asked about them, a question that begins with the word how. But that statement alone is not sufficient to clarify, so we say, there are 2 levels of human perception of his environment, one of which is linked to the other, the connection of the lowest to the highest, or the connection of the first step to the next step in the stages of progress. They are the level of perception on which we deal in our practical lives, and the level of awareness that we rise to in the life of scientific research in its advanced forms, such as what we see in physics and chemistry sciences. As for the first level in which people deal with each other in their daily lives, the focus then is to refer to things and events with their apparent descriptions to the senses or with their benefits and ways of using them in practical life. So it is said, water, a chair, a tree, a spoon, salt, paper, and air. Clothes, food, etc., etc. If you look closely at this huge family of language words as people use them in their daily lives, you will find that they, in fact, have connotations that deal with things and beings in their entirety and not in their analytical elements. So, water is taken as if it were a non-existent entity. It decomposes into its 2 elements, oxygen and hydrogen. Because it is a water it composed in the way we are familiar with it in our lives, it is used for our various purposes related to it, such as drinking, washing, irrigation, swimming, and so on. Even if the science of chemistry dealt with it, it did not make it a water in the compound way that we know it, but rather it remained analyzed in its tubes and laboratories until it reached its simple chemical units and the methods of their interaction through which water becomes water. We may read chemistry books and physics books and do not find the word a water in them. Because it is a non-scientific word, even though it is the word that has no other word in the field of daily use, so if you say water in your speech, you are referring to this substance from its equalitative aspect, but if science turns it into 2 yards 1, i.e., into 2 atoms of hydrogen and 1 atom of oxygen, all of which reacted together to form an atom of water. So here the approach is from the quantitative aspect. The first aspect is current life and the other aspect is scientific research. Likewise, it is not part of the language of advanced science to say, a chair, a spoon, etc. For him, these are ultimately compounds of elements that the science of chemistry can identify, just as the science of physics can reduce them to atoms that differ according to their electronegativity. If we say about the language of ongoing life that it depends, in its reference to things, on their quality, that is, on the ways in which they directly affect the senses, and the ways in which they are used and benefited in the shared life between people, we say about the language of science that it depends first and foremost, not on things as a whole nor on beings when they are complex, but on analyzing them into its components, including in those components the quantities that were included in the state of composition. It is clear that the angle of qualitative perception of things does not help anyone in making these things if he wants to make them. As for the angle of quantitative perception of the quantities with which each element is added in the composition of things, it enables whoever wants, and whoever has the knowledge and ability, to enable him to make a thing if he wants to make it. For example, if people started repeating the word water in the world of daily use, millions after millions of times, the chemist would not be able, from this word alone, to make water in his laboratory if he wanted to. But if we replace the word water with its scientific name based on analysis and knowledge of quantity, then we say 2 hands 1. The chemist knew how to make a drop of water by adding these mentioned elements in their specific quantities and in their interaction, so he had in his hands the required drop of water after he had it was not. It is not of any benefit to scientific research to say, for example, as we say in our current conversations, that the shortcomings in our society are poverty, ignorance, and disease, because these 3 words, despite their importance in daily conversations, in political statements, and in journalistic investigations, in those non-scientific fields, awaken attention and arouse interest. When science begins to address its topics, the qualitative language mentioned in the areas of excitement and awakening must be transformed into quantitative language in order to enable productive science to follow its precise methodological path. The word poverty is not what is required then. Rather, what is required is to translate it numerically, such as saying that the average Egyptian's income is now £100 a year, which is average if measured against the level of average incomes in the world, in the lowest bracket. Then what? Then I must also supplement this numerical perception with another numerical perception, which is the minimum average income as we want it to be. If this required minimum is £200 per year, we know that the required increase in national income is about £4,000 million. With this, I have put the first point in scientific planning, because, in light of this required amount, I proceed to envision various projects that could bring such income to the nation. Thus, we see that the first necessary condition in any productive scientific thinking is to transform the qualitative language into its equivalent in the language of numbers. And say something like this about the concept of ignorance, since the word alone does not guide us to what should be done. As we said, it is a word whose meaning is a how. It is suitable for current conversations and stimulates enthusiasm, but it is of no use in itself in determining what is to be done, even if we did not transform it into the language of numbers. That is, to quantitative significance, the path is clear, so we start with the question, ignorance of what? How many people do you want to teach? How many schools can be prepared? How long is the required period? How many teachers, how many books, and therefore how much money is enough for all of this? The matter, as you can see, depends on our answer to the first question, ignorance of what? I don't know how to read, write, and arithmetic? Or in addition, through the methods of making in the fields of work? The first answer to questions like these determines for us the type of schools required, as well as the types of teachers to be prepared, and so on. There is a big difference between the familiar language of speech and the language of science. Therefore, one of the most important foundations of scientific thinking is that we use science terminology and concepts. Because this is enough to open before our eyes the field of scientific research, where it is and how it is conducted. Take, for example, the concept of color as we know it in our ordinary conversations and its concept as known by natural scientists. In our practical life, we distinguish between red, yellow, green, and other colors. We see them in everything. In plants, in flowers, in clothes, in rocks, and in other creatures that our world is crowded with. In science, color is light, which changes with the lengths of light waves. The science of light is not concerned with how the human eye sees or what it sees, but rather with the wavelengths that it measures. Therefore, the blind person is like the seeing person in studying the science of light, as it is related to lengths, angles, and equations. And once again we say, if a person stopped at the limits of his qualitative perception of colors, as the sense of sight perceives things directly, it would be impossible for him to design a device that transmits these colors from a distance, like a color television, for example. But when he translates colors into light waves of known lengths, then the way opens before him towards imagining the device that transmits these waves. And say the same for the voice. The science of sound is not based on the way the ears hear the sounds of nature, from an audible word to the rustle of the wind in tree leaves or the crash of waves in the sea. No, rather the science of sound is based on the study of sound waves, what their lengths are, how they are measured, and at what angles the sound is reflected or refracted. If he became familiar with this mathematical aspect of the phenomenon, he could control it however he wanted. The accuracy of scientific thinking requires transforming our concepts into a quantitative, after they were of a qualitative nature in our daily perception. The different sciences differ in the extent of their progress to the same extent as they differ in their quantitative control of their concepts. Physics, for example, is ahead of economics or psychology, to the same degree that it was able to transform its language into mathematical formulas. You may ask me, but if this is possible in the world of physics and the like, is it possible in the human world? What are we doing in the human sciences, from economics to psychology to sociology, politics, and others? If we are going to say a brief word later about the scientific position in relation to the human sciences, we hasten here to give a brief answer, and we say that these sciences, like others, advance on the same basis and to the same degree, by which they can transform from the language of quality to the language of quantity. For example, instead of saying in psychology, "Oh, intelligence," we try to invent the way in which we measure that intelligence numerically. Otherwise, we freeze at a word with which we express merely vague impressions about individual people. Look at the concept of emotion, how it was in natural science during its early historical stages, and how it became after its widespread transformation in the European Renaissance at the hands of Galileo, Newton, and others. Natural science's conception of motion in its early stages was a qualitative one. Aristotle, for example, divided it into types according to their directions. He said that there is an ever-rising motion, such as the motion of a flame, an ever-declining motion, like the motion of a falling stone, and a circular motion, which to him is the most complete type, like the motion of celestial bodies. In its orbits, if we had stopped at this descriptive stage of the types of movement as our senses see them in the things around us, we would never have been able to invent the train, the car, or the rocket, for what benefit would it do us to describe what we see and then do nothing after that? But Galileo, 1564 to 1642 AD, came and took another look that turned the matter upside down. He wanted to abstract movement from moving objects, so that he would not be preoccupied with their direction and say that the flame is rising, the stone is falling, and the planet is rotating. No, he abstracted movement alone and tried to make it homogeneous in nature. It makes no difference whether the mover is a stone, a flame, or water flowing through a river. The new scientific goal is not to describe what is witnessed, but rather to extract the quantitative law that determines speed for us and what affects it, and then we obtain the laws of movement of objects. And soon after that we increased our knowledge of the movement of celestial bodies, and astronomy advanced, and then it is only that Newton brought out the law of gravitation, and so on. With the likes of these quantum laws, it became possible for man to control the movement of matter at the required speed, thus making modern civilizational progress unprecedented. The difference between quantity and quality is the difference between what European Renaissance scientists and philosophers called the primary qualities and the secondary qualities of things. What did they mean by this division? Galileo, Newton, Locke, and others said that things have fixed characteristics that do not change through the process of human sensory perception. For example, the fact that a particular body is round, spherical, square, or triangular, these are qualities that remain in it whether a person perceives them with his sight or not. As for the body being yellow or green, and being sweet or bitter, and being silent or having sound, this is another type of characteristic which does not exist in things, but is created by the human perceptual system. What comes to the eye from a colored body is a light wave of a certain length, and the eye and its appendages interpret it from the system. Visual to a specific color, as well as in the case of sound, and in the case of taste, etc. As for the fixed attributes of the first group, they are what they called primary attributes, and they are the only ones that are suitable as a basis for sciences. As for the attributes that our sensory perception created morally, they are secondary attributes, and they are not suitable as a basis for sciences. Based on this division, the scientific researcher, with regard to every phenomenon he wanted to investigate using the scientific method, had to seek a method for it that subtracted the perceptual aspects that the senses created on their own, in order to retain the objective aspects that could be subjected to quantitative measurement. For the two, scientific thinking is objective. The division into a how and how much in which we summarize the statement and with which we try to show that scientific thinking gets rid of qualitative meanings as much as possible in order to limit itself to quantitative aspects alone. I say that this division has led us to dividing attributes into two types, attributes primary and secondary qualities, which is a division that was widespread in the European Renaissance between men of science and men of philosophy alike, and philosophy, in most of its cases, is nothing but a philosophy of science, and this was their desire to make a clear distinction between what is suitable for scientific treatment and what is not, and it is permissible for us to look at that same division from the angle of objectivity and subjectivity. So we find that the primary qualities in things are the objective qualities, that is, they are qualities that do not depend on the way human perception of things and phenomena is. As for the secondary qualities, in contrast to their counterparts, they are the intrinsic qualities, which human perception creates on its own, by virtue of the structure of the human cognitive system, and such as colors, tastes and sounds, while the objective primary qualities, which are independent in their existence from human perception of them, can be measured in terms of dimensions, weights, speeds, and so on. We see that the subjective secondary qualities, which depend in their existence on the way humans perceive them, are not measurable, and therefore they are not capable of being converted into a mathematical quantity. This means that when we define scientific thinking as what deals with the quantitative aspects of phenomena, we were at the same time tantamount to saying that scientific thinking requires that it be objective, not subjective. Its objectivity is enough to protect it from differences in individual views, which are often controlled by whims, desires, and emotional states in general. Yes, philosophers of science, while trying to define this aspect of scientific thinking, I mean the aspect of objectivity, encounter many difficulties in defining it. Because as long as the human being is himself the instrument of perception with his sense organs and the logic of the mind, how can the situation that is the subject of research be stripped of his human self with all that is in it? While we rely, for example, on accurate observations and the experiments that we conduct, we ultimately depend on our senses and on the devices with which we expand the scope of those senses. In both cases, we cannot perceive of the facts of nature except what these devices can perceive, such as the fisherman's net when he throws it into the water. It only catches fish whose eyes can prevent it from escaping. As for what is smaller in size than its eyes, it escapes. This is what is said about all our cognitive systems. They grab from facts what they are able to catch. Therefore, there are subjective limits. When we perceive it, we first perceive it, which makes the required objectivity incomplete. This is all true, but it does not prevent us from stipulating that scientific thinking should be as objective as humanly possible. Scientific development and the advancement of scientific equipment will ensure, over time, that a person will continue to correct himself and increase the accuracy of his knowledge. At least we require that scientific thinking adhere to what is common among specialists in the specific field of research. No one will claim to them, for example, that he has realized the truth of what changes his apparent senses or changes his scientific equipment, in which all members of the scientific family can participate with him. It is as if he says that he has realized what he has realized with a supernatural ability that distinguishes him above all his colleagues. This may or may not be true, but in any case it does not fall within the scientific field, as long as it is not possible for the scientific community to participate in the review and investigation. Scientific truth is objective in the sense that all specialists participate in its perception, and it is not unique to some over others under the pretext that they have a sixth sense that they only enjoy, or that they have insight that is unique to them, or that they perceive the facts with their hearts before their minds, and other such statements. We want to accuse her of lying, because they may be completely truthful statements in their field, but despite that, they are not considered scientific thinking, because they lack the quality of objectivity that allows anyone who wants, and who has sufficient education and training, to review the ideas presented to verify their scientific veracity. Scientific thinking is a difficult task for those who are not trained to do it. The general public is distressed if it demands from its members the accuracy of expression in a way that rids it of emotional superfluities, so all that remains is the determination of the scientific truth alone. The general public is distressed because many people have become accustomed to the characteristics of expression in their language, which are characteristics that can hardly differentiate between a required word and an extra one. He said this phrase, "It is unfortunate that illiteracy is widespread in the Arab world at such a high rate." It is a statement that appears to be a rational, scientific report, but its reality is an expression charged with conscience, which is outside the scope of reason and the scope of science together. He said, "It is unfortunate." Rather, he refers to his emotional state, not to an aspect of the external reality that he is talking about, and whether he mentions this part in his sentence or not, nothing changes about the reality described. His saying of fascism expresses a general impression devoid of any specificity. Therefore, it does not have the objectivity that others can participate in reporting the incident, and thus you see that many subjective threads have crept into the statement, making it lose its scientificity. It happened to me one day that I was lecturing on this meaning, and the students were astonished when I wanted to make the matter more clear, so I said that if someone said, "The sun has risen today at 5 o'clock," the word "may" in his first sentence goes outside the scientific scope, because it does not add or subtract from the aspects of the incident that we mentioned. If it conveys a meaning, it merely conveys a confirmation. Emphasis is a special, inner, emotional quality that the speaker wanted to influence the listener, but it is not something that refers to anything in external existence as it happened. Such emotional words are the ones that abound in literary expression, whether poetry or artistic prose, because what is meant there is the emotional side of the speaker and the listener alike, but in the sciences you do not find them, and if you wish, browse a book on sports, physics, or chemistry. You will not read in it a phrase such as, "It is a pity," or any other expression that expresses amazement, affirmation, or hope. Yes, we may find such emotionally charged expressions in human studies, such as history, literary criticism, and sociology. But the more it was charged with emotional energy in its expression, the more it lost the objectivity of the scientific formulation. It is no wonder that the advanced precise sciences are dry in their terminology, because it resorts to indicative symbols alone, without adding anything that is intended to indicate what is stirring in the heart of the scientific researcher. Hence, scientific writing is neutral, and the student cannot infer from it the personality of its writer. As for literary writing, it contains biased emotional expression that is sufficient for the reader to learn a lot about the personality of the writer. Hence, purely scientific books were easier to translate into other languages than literary books, because if a scientific term is replaced by an equivalent term from another language, it does not lose anything, nor does a phrase that carries a tremor of conscience. Languages vary in their emotional content, or rather in their poetic content, by varying in the abundance of words that refer to the interior of a person more than they refer to the reality of external things. I believe that the Arabic language is one of the languages that is most deeply immersed in the speaker's conscience. Therefore, we saw difficulty in translating it into other languages, compared to translating those other languages into Arabic. The poetic abundance in a language gives its timbre a special importance. If we remember that the timbre of expression does not enter into precise, objective scientific expression, we will know that the more we rely on timbre, the less dry scientific declarative result will be in the particular phrase with timbre. The purely objective aspect of the scientific statement only refers to a part of the actual reality, which any competent listener can review to be assured of its correctness. From the characteristic of objectivity that characterizes scientific thinking, another very important characteristic branches out in determining what we want to determine, and that is that the scientific issue presented to scientists should be able to be investigated by means that highlight its error if it is a wrong issue. When we said about scientific thinking that it is the objective, we meant to say, accordingly, that the scientific issue is a social issue and not an individual issue that concerns its author alone. I mean that if a scientific researcher announces an idea and claims that it is a result he has led to from his research, then he has no right to present to people, i.e. fellow scientists in his field of specialization, the evidence of its veracity, and he does not have the right to make it a matter of his own. I realize that, by a means that only he owns and not all other people, starting from the language or symbols in which he presents his idea, it must be a language or symbols that have been used by scholars of the field in which he is researching, so that what he means is understandable to everyone who wants these scholars to follow him, review him, and discuss what he has presented. Therefore, his proposed idea must be something that can be verified by the common senses of sight, hearing, and others, and not, for example, be one of the supernatural things whose secret is difficult for people's eyes and ears to comprehend. Here two important points arise that are worth mentioning. The first is the words that indicate values, such as moral values and aesthetic values. Is it permissible to use them in a scientific statement? Is it permissible for a physicist, for example, to announce to people that it is not good for humanity to explode an atom? I mean, is it permissible for him to announce this since he is a physicist? It is true that, as a human being among all other people, he enjoys all the rights to say that others enjoy, on the condition that he does not exceed those others in the scale of opinions, as long as the opinion he presents is not within his scientific specialty. It is clear that the issue of good and evil is not among the issues of physics in which he has the priority of opinion over others. No, words indicating values of all kinds are not included in the scientific context. We often hear commentators citing eminent scientists in support of their own doctrines of beliefs and values, as if it were said, for example, that Einstein believed in the supreme value of human conscience and that Darwin did not oppose, with his biological theory, the necessity of adhering to virtue, and so on, as if Einstein or Darwin have included these statements within their scientific theories, as if each of them, if we took him out of the field of his scientific specialization, would have the upper hand over others in all other opinions. What we want to emphasize here is that science is tied to its issues, and men of science are listened to in their scientific fields, and as for what concerns human values, it is not one of the issues of science, nor is it among the issues in which scientists are listened to except in the sense that they are people like other people. The other point that we also want to highlight is that when we said that one of the most important conditions for a scientific issue is that specialists in its field be able to subject it to investigation by means of science and either accept it after that or reject it, we also wanted to say that the average person in his ordinary life, if he wants to clarify in a certain statement whether there are facts that are characterized by science, even from afar, or something that has no scientific status at all, then he should ask himself, what changes in the world of things between the two states of being correct? What is wrong with this statement? That is, if we impose a special status and arrangement for those things in the event that the aforementioned statement is true, then what about the status and arrangement of things in the event that they are wrong? If we do not find a difference in this between the cases of right and wrong, we know that this statement is far from being included in the set of scientific facts. To give an example of this, we say, there was a time when people lived at the beginning of history, when they thought that plants had a spirit that took care of them, as well as that rain, volcanoes, and every phenomenon of nature around them, to the point that people at that time feared the tyranny of these spirits hidden behind the phenomena, each of which took care of them. Its own phenomenon, so they used to offer sacrifices to it to gain its approval. Now we ask, what is the method of plant growth and fruition if that belief is true, and then what is the method of growth and fruition if it is false? As long as we can now explain every aspect of growth and fruition by its cause, such as soil, sun, air, and other things known to botanists, there is no longer a function for the spirit in charge of plants to perform, and therefore there is no longer any difference in the placement and arrangement of things between the belief being sound or not. Corrupt. 5. What about the humanities? During the academic year 1953 to 1954 AD, I was a visiting professor at one of the universities in the United States of America, and the current tradition at that university was to host men from the scientific summits in America itself, so that the visitor would spend a week or so lecturing the university students together and then holding scientific seminars with them. Faculty members. Among these distinguished visitors, during my stay there, was Henry Margino, who had previously been a professor of physics at the University of Bell and then devoted his interest to the philosophy of science. Therefore, his seminars with the faculty during that visit revolved around this topic, especially with regard to the natural sciences and especially physics, and he wanted to conclude his seminars with a seminar on the philosophy of the human sciences. What are the basic rules in their curricula? He began his speech that day with a question that he posed to us, the group of professors present, saying, I spoke to you before about the philosophy of method in the fields of natural science, and I now want to listen to what you see about this topic in the field of human sciences. Here a short moment of silence occurred, and then I began the conversation after that. I was among them a visitor who had come to them from a distant country whose culture differed from what they imagined, and as if I felt the eyes turning towards me to begin the conversation, so I began with a question that I directed to Henri Margino. Isn't there an introduction to our research on certain characteristics of the approach to the humanities, which implies that we assumed a difference between it and the natural sciences in the method of approach? My opinion is that we start with another assumption, which is that every phenomenon that is subject to observation can be dealt with in the manner of natural sciences, with no difference in that between a human phenomenon, a climate phenomenon, a phenomenon in the Earth's minerals, or anything else, until we exhaust the possibilities of the scientific method in this sense. If there remains a remainder of the human phenomenon that cannot be subjected to the natural method, then we will either create a method of its own for it, or we will transfer it to a field other than the field of science. What are the human sciences if they are not attempts to stereotype human behavior in various circumstances, whether economic, psychological, or social? Therefore, the matter in it is no more than observations and experiences that are collected for us in an organized manner, then classified into categories, and then a general principle is assumed for each category that explains them. There is no fundamental difference between it and climatic phenomena, for example, or the phenomena of light and sound in physics. Oh God, unless human behavior is more complex, but this increase in the complexity of the phenomenon does not negate it from being a phenomenon in any case. If it is more difficult to understand, it requires more analysis. As long as human behavior exists in actual, witnessed existence, therefore, it is like every other reality that occurs in existence. Perhaps what prompted a group of philosophers of science to doubt the possibility of the human sciences being included with the natural sciences in one method is their difficulty on the one hand, and their backwardness and distance from accuracy when compared to the natural sciences on the other hand. However, all of this does not contradict the conditions of the scientific method as we know it in the advanced sciences. This approach has only two basic conditions. They are conducting observations and experiments in which we are safe from error, then drawing inspiration from these observations and experiments into a theory that coordinates the observed details into a single structure, and it can be returned to the field of application so that it is valid in this field and there is nothing in the human sciences that contradicts these two conditions. Several factors have led to the backwardness of these sciences that can be eliminated through systematic training. One of the most important obstacles that prevented the human sciences from progressing as well as the natural sciences was their use of qualitative concepts for which they did not try to find a way to transform them into quantitative formulas. For example, you see them using words such as class, society, and intelligence, utility, democracy, instincts, etc., as if these words have simple meanings and their meanings can be controlled in a way that prevents differences in their understanding and helps to treat them in a manner similar to the way we treat words such as heat, light, sound, electricity, and the like. It is difficult for us to imagine a path to scientific progress before we find the way by which qualitative meanings are transformed into quantitative degrees that can be measured with a device devised for each field. It would have been possible, for example, for the temperature to remain based on an approximate estimate that is of no use if specialized scientists had not invented a device, the thermometer, that measures the degree so that the temperature becomes a graduated scale from the lowest degree that can be measured to the highest degree that can be measured. Instead of saying a hot or a cold, we say such and such a degree below zero or such and such a degree above zero. This precision enables us to treat objects in accordance with the required temperature and so on in all perceptions in the field of science. As for the human sciences, we still, for example, in the fields of economics, politics, psychology, and sociology, we use words that we only want their meanings in dictionaries or in daily use, without having the means to translate them into mathematical degrees, although these human sciences are striving towards this quantitative translation of their concepts little by little and often. If you achieve success, you will advance to the extent you succeed. Another obstacle to the human sciences is that, to this day, they still allow themselves to use self-denoting words, such as words that indicate values or words that arouse the conscience, not being satisfied with the language of the mind. How easy it is for psychology to use adjectives to describe individual people, such as normal and abnormal, or such as extrovert, introvert, aggressive, and others, all of which are words that carry with them values that make objective scientific accuracy impossible. Have you known in the sciences of physics and chemistry a phenomenon that they describe as abnormal? Nature does not know abnormalities. Every phenomenon in nature has its own law under which the phenomenon falls. The human individual whom we call abnormal because of his mental backwardness from his peers or because his behavior differs from the behavior of the majority of his neighbors is in itself a phenomenon that is subject to research, analysis, and codification. If we do not find it included under the laws that include all other people, it has its own laws that explain it. The path to methodological progress will not be open for the human sciences unless we make a sharp distinction between interpreting phenomena as they occur, with laws that enable us to predict the course of those phenomena, and between moral or aesthetic values. This does not mean that people's lives do without a set of values, but each side has its own mission to perform. With correct scientific study, we'd understand the affairs of reality as they are, and with values we learn how we should behave toward them. Among the factors that also accompanied the human sciences, which led to their backwardness compared to the natural sciences, was their introduction of the idea of optimal goals into their fields of research. In politics, economics, and society, you see us adhering to principles on which we shape our behavior, and we consider it a violation of the full standards of human life not to behave in accordance with those principles and what they dictate. There is nothing wrong with that, but the whole problem lies in the way we understand the word principles, and I mean when the field is the field of scientific thinking in a specific situation, as we often miss the meaning that goes along with scientific thinking and does not oppose it. It is that the principles in the human sciences are like what are called hypotheses in the fields of natural sciences. If the hypotheses in these fields are invalid if they do not succeed when applied, then we replace them with other hypotheses until we find the hypothesis that is valid when applied. Then we call it a scientific theory or a scientific law. This is how the word principles should be understood in the human sciences. It is worthy of our adherence to it as long as it is proven to us that it is the one that leads us to the life we want. However, if it becomes clear that a certain principle would, if we adhere to it in our behavior, lead us to a backward, bad, poor, sick, and floundering life, then the principle must be changed with another principle. Otherwise, the mistake in this regard is to look at the principles as if they were immutable facts of the universe, such as the rising and setting of the sun and the succession of the seasons throughout the year. These are examples of the obstacles that hinder the human sciences, so do not leave them free to follow the methods of science as defined by the natural sciences, which have reached a degree of accuracy that makes them a model to be emulated by other sciences. However, this should not make us forget another position taken by a group of philosophers of science. As they say, the human sciences have special circumstances that prevent them from fabricating the scientific methods known in the natural sciences, including that the regularity in human life is less apparent than the regularity in the phenomena of nature. Although the phenomena of nature fall into patterns that can be perceived and the scientific laws that govern them can be extracted, human individuals and their peoples do not. He rejects its progress in such a homogeneous manner, including that it is possible for natural scientists to repeat the occurrence of the phenomenon that they are researching whenever they want in their laboratories. As for human phenomena, they often occur only once and then do not return, nor are they something that can be repeated. However, the response to objections such as what we mentioned earlier, which is that the differences between the two fields are upon analysis differences in the degree of structure, not differences in the nature of the matters themselves. They also say, in what they say, an apology for not adhering to the natural scientific method in the fields of the human sciences. Man has free will with which he can change the causal course of things. How then can we imagine that he himself is subject to causal connections? And that the experiments that we conduct in laboratories on inanimate objects, plants, and animals, it is impossible to conduct the same on humans, and that it is not surprising that we find the laws of natural sciences general and absolute that do not change with change in place and time. As for man, even if we control the laws of his behavior, we control them in the field of a specific civilization, a specific era, and a specific society, such that we cannot expand its application to include all of the worlds in every place and in every era of time. They also say that what has helped the natural sciences to progress and become accurate are the standard devices through which perceptions can be transformed into numbers and mathematical formulas. And all of this is impossible for humans. We respond to all of this with a brief statement, saying, if it is proven that there is something in human life that cannot be subjected to the natural scientific method, then let it have a field other than the field of science, or else we admit from the beginning that it is impossible, and then we continue to think that it is a science. Sociology, a science of psychology, and a science of politics, an unacceptable contradiction. However, what deceives the objectors of the fundamental difference between human life and natural phenomena, and note well that here we limit human life only to what can be subjected to science, acknowledging that there are other aspects of that life for which we do not claim such and even do not want it for them. I say that what those objecting to the illusion that there are fundamental differences between the two fields, is that they look at the human being in terms of his emotional or existential content, while science, both in human life and in the phenomena of nature, is mainly focused on the relations that bind the parties to each other, and these relations wherever it was possible to measure it if we created devices to measure it, and therefore it is something that can be formulated in mathematical functions that enable us to predict what will happen before it happens, if certain conditions exist for it. Rather, it enables us to find what we want to find in terms of human conditions as long as we knew its laws. Otherwise, how can we claim that we have established a scientific plan according to which our lives will follow, in production, education, or otherwise, for a period of a number of years that we specify? 6. Knowledge alone is not enough. I return to what I started with, which is that human life is multifaceted and has many threads. It is like a palace with many rooms and spacious halls, with many doors and windows. Every door leads you to a place other than what the other door leads to, and every window overlooks a scene other than the scene you see from the other window. This is an undeniable matter in a person's life. But in these pages, we limit ourselves to one room of the palace, one of its windows, and one of its doors. As for the one room that we limited ourselves to here, it is the science room, and as for the window that we opened without all the other windows, it is the one that overlooks the external reality that can be its calculation is in numbers, and as for the door that brings us into that room to overlook that scene, it is the scientific method, the foundations of which we have mentioned briefly. We say this as a warning to those who are interested in asking us, and there are readers who will do so despite every warning. Do you want, with this short journey in the fields of scientific thinking, to exclude from consideration beings who cannot be witnessed by sight or heard by ears? Do you want science and thinking on its foundations to spread its broad wings to include, among other things, truths against which it is powerless, such as love and hate, courage and cowardice, mercy and cruelty? Can science explain to us how genius creates when it creates? How does a great musician compose himself to organize what no one else can organize? Can science tell us where the difference in physical composition lies between Al-Ma'ri and Shakespeare on the one hand and the common people on the other? If the components of the world are the atoms whose amounts science wants to calculate in order to place them in mathematical functions, then where can we place meanings such as freedom and equality in a world like this, and where can we place the ideals that humans aspire to achieve? Supporters of the scientific method say that it is necessary to formulate laws that allow us to predict what will happen in certain circumstances and allow us to find what we want to find after it did not exist. Does this mean that nothing new is added to man and to the world that is impossible to predict today? On the basis of what might have been? Then, has the vastness of the universe and the vastness of life become so narrow that it cannot be viewed as it really is except from one angle, which is the angle of science and its method? Is everything to you more than the mind, its logic, sports, and its language? Where then do you want to place the intuitions of the mystics and the glimpses of the poets? What do you say about types of conscience that disturb the heart, without us having ways to express them in an organized and understandable scientific word similar to what the method of science wants us to understand and arrange? These are all questions that I ask the reader before he surprises me after reading these pages. These are questions that I ask first to say with full mouth that science is one room with one door and one window, rather than a palace in which there are many rooms, doors and windows. But here we are required to talk about science and not all other aspects. We are here like a walker in a city looking for a commodity that he wants to buy, so he asks about the way to where it was displayed, then he stood there to look, examine, and make the purchase. Is it permissible for someone to blame him? How did you go all this way to buy a handful of foam and lentils, even though there are shops that sell gold, silver, pearls, and coral? How does this humble food affect you when you have lamb, beef, chicken, and fish? Yes, these are all goods offered in the market, but unfortunately for him, he left the house looking for one thing that he was asked to buy, which is that humble fist of foam and lentils. This is the case in these pages. We intended with them one type of aspect of cognition, which is scientific cognition, and one type of beings, which are the beings that can be subjected to observations and experiments, in order to finally formulate from them what are called the laws of science. The matter, my friend, is in this. The vast universe and human life, with all its complexity and all its sublimity, is what you came to choose as a subject for consideration, but the moment you finish choosing scientific consideration and its method, you no longer have the right to mix one matter with another. If your choice is to learn how the natural environment in which you live is structured, and how your behavior is structured within it and influenced by its incentives and organisms, in order to shape that environment and this behavior in the image you desire, then you have no path to your goal except scientific knowledge or the method that scientists' experiments have shown. For many centuries, it has been considered the method that leads to correct and accurate scientific knowledge. I am aware that a person is often distressed by this world and everything in it, so he begins to seek another world, depicting it for himself with his conscience through poetry, stories, photography, or other means. Then he does not need a knowledge as much as he needs imagination and creativity. But if he insists on living in the real world, and treating people on the basis of this same reality, then he will have no alternative on that day to science and its method. You are in a life of imagination and illusions, setting up your laboratory within yourself, and cooking your hope for food as you please, not bound by what is there. There are plants, animals, and minerals on the face of the earth, but in dealing with actual reality, you are forced to place your laboratory outside your body, and to cook food from what grows in the earth, or swims in the water or the sky. But even the delusional person while he is delusional, and the artist while he is creating his arts, if he wants for some reason to know how this strange illusion works in himself, or to know how the artist completes his creativity of poetry and music, then he must then turn to a man, science, and the owner of the scientific method to analyze for him this what is happening in itself. Science, with its method, paints for us an accurate picture of what is there, what was and what will be, and after that we can take for ourselves the position we desire, so who knows? You may be inclined in your soul to Sufism, regardless of what has been, is, or will be, in order to turn your heart to other paths, or you may see the picture drawn by science of what is reality, and you see it as something that is not consistent with moral principles that you want to preserve, as if science gives you a picture. It is correct about the atom, its composition, and the method of exploding it. After that, it is left to you to choose the position you take regarding it. All of this does not negate the fact that science has its own method for whomever it wants, and those who call for artificial science in people's lives limit their call to what is suitable for science and its method, and as for what is not suitable for the rest. Aspects, he is entrusted with other means that are not objectionable. A person is not a complete mind. Rather, he is a mixture of reason and non-mind, such as emotions, desires, and lusts, and both reason and non-mind have their importance. There is no shame in a person being both this and that, but the defect is in mixing them together. Because if you allow the irrational aspects to infiltrate the realm of the mind, then it will be corrupted and it will be corrupted, and the person will be lost and torn apart in what is of no use to him. It is astonishing that we find this confusion, despite its seriousness, widespread among us and drawing attention. What was intended for the life of conscience, some of us are trying to insert into it. In the logic of reason, that is, to introduce him into the field of knowledge, thinking that this is an honor, glorification, and support for him, although if this indicates anything, it only indicates that the one who attempted such an attempt was not confident in the sufficiency of his conscience, so he wanted to look for a support for him from outside himself, lest he fall and collapse. Let us conclude our discussion by saying that the ultimate goal that a human being seeks for himself, I believe, is to be a free being, and this psychological freedom can be achieved through both paths, knowledge and conscience. With knowledge, we know the laws of natural phenomena, so we control them so that they are subject to what we want from them. With knowledge, we break the restrictions of space and time imposed on us by instinct. If instinct dictates that the legs move at a certain speed, and if instinct dictates that the sound of speech should only reach a short distance measured in meters, and if the nature of the entire body requires that it be drawn towards the earth and not beyond its cover, then by obeying the laws of nature we fly, and our voice reaches the ends of the earth, and we emerge from the shackles and pull of the earth. With knowledge, we cultivate the desert, change the course of the river, bring down rain, and resist disease, so we break the chains with these and similar abilities. What draws us to a specific place and within a known period of time is our extravagantly short lifespan if we attribute it to the immortality we seek. Through conscience, we break other restrictions in order to be liberated. By rising above the narrow limits of selfishness and rising, if our resolve so desires, from the restrictions of need, such as fasting from food and drink from time to time, spending for the sake of the common good, and other aspects of our lives in which we are guided by the inspiration of our faith, all of these are types. Freedom is achieved for us by other desires in our hearts other than the desires and methods of reason. And freedom in its two parts, what is achieved through knowledge of the laws of nature and the laws of human behavior, and what is achieved through conscience and faith. I say that this freedom in its two parts, perhaps it is the trust that was offered to the heavens, the earth, and the mountains, but they refused to carry it, and they were afraid of it, and man carried it.